Welcome to this video about solving one-step equations, but that may seem simple, so we're going to kick it up just a little bit as we look at how would we use inverse operations to solve an equations. First of all, we're going to kick it up using some decimals and remembering what we know about 5th grade, but we're also going to add in negative numbers. So we've got to remember how those rules apply about positives and negatives and pulling it all together, but starting with under this basic premise of solving one-step equations. So let's go through the process and see if we can understand how this all works once again. So we know an equation is like an equal sign. It is a balance where both sides of the equation have to maintain a balance. So with that in mind, we know the golden rule needs to apply. What we do to one side of the equation, we must do to the other side to keep it balanced. In other words, if I added 2 to one side, I'd have to add 2 to the other side, or we'd be out of balance. Same thing if I subtracted 3 from one side, I would subtract 3 from the other. If I would divide by a negative number on one side, I would have to divide by a negative number on the other. We just have to keep those sides balanced. We need to focus on different things, and so let's go through what we need to focus on, because our goal at the end of the day is to get the variable alone to find out what that variable equals. In other words, our goal is to solve the equation to find out what number will make it true. What number can we put in that place so that that equal sign will maintain that balance, that both things are going on. Now, how are we going to accomplish this? We're going to use something called inverse operations. Now, inverse means opposite. In operations, we're talking about adding, subtracting, multiplying, and dividing. So we need to remember what opposites ones are. We know that adding is the opposite of subtracting. We also know that multiplying is the opposite of dividing. So if we keep that in mind as we work our way through these problems and understanding how it works, these are very simple, and we're going to show all the steps. Now remember, we're using decimals and integers, positives and negatives, because we want to show there is a level of difficulty at some point in time, but we want to show how do we do this even when things are difficult in front of us. So let's take a look at this equation. So I have an example here. 5 3/10 plus p equals negative 3 2/10. So before we even tackle this problem, let's take a look at what this would be if I put it on a balance. So here is my balance, and right here in the middle where this is my equal sign. So on one side, I have this positive 5.3, and then I have this cup, which is right side up, which is going to represent my positive p, my variable. I have no idea what that number is. So if my goal is to get this alone, then I need to take away the 5.3. Right? So taking away 5.3 means I'm going to subtract this from this side. But if I subtract negative 5.3 from this side, I have to subtract 5.3 from the other side as well. So what does that look like in our equation? All right, so let's take a look. First thing I'm going to do is I'm going to keep our sides separate. So just like we did up here with our little balance, we have that V in the middle that keeps things balanced. We're going to use this line to keep our balance to make sure that we're focusing on the side that has the variable. As we saw, this is a positive 5 3/10. So what I want to do is the opposite, or the inverse. So I want to subtract 5 3/10 from one side, and to keep the balance, I'm going to subtract it from the other side. Now, what that does for me by subtracting it is right here. This 5 3/10 and negative 5 3/10, this is what we call a zero pair. This is going to go to 0. It's going to go away and zero out. The reason we want to do that is because now we get the variable alone. So we're going to bring that variable down, which happens to be a p, and now we're going to do some mathematics. We have a negative 3 2/10 and a negative 5 3/10. If it wasn't stacked this way, it would look like this: negative 3 2/10 minus 5 3/10. So this is what it would look like, and we know that when we have a subtraction problem, we are going to add the opposite. So this kind of gives us a little bit look. We know then we're adding these two negatives together. When we do that, we're going to get negative 8 5/10. Now, in equations, we have to make sure, and we can't always say, yes, we're correct. We have to check. So what we're going to do is we're going to check our solution. The way we do that, theoretically, and this is what we should do every time, is rewrite the equation exactly as we started. And what I've just written here in black is what we started with, correct? So I'm going to separate my sides again. And I'm also, this time though, we think, as we're looking at this, right, we think that we have an opportunity here and what this P is. So I'm going to erase the P, and in the P spot, I'm going to put what we came up with, a negative 8 5/10. So let's think about this as it comes together. We have a positive number and a negative number. Now, I know that when they're opposite signs and I'm adding them, I'm really subtracting them. And I see that I have more negatives. So when I subtract these two numbers from each other, I will end up with a negative 3 2/10. And that's exactly what the other side is. So since the other side is equal, they are both equal. We know that it checks out. And then we know that this is indeed our solution. So I've kind of went through this a little bit slow so that we can understand where all the numbers are coming from. But we should be able to, when we're doing this kind of work, we should be able to, and I want to draw a line right through here. Everything that's inside this blue box that I'm drawing right now, this highlighted blue box here, this is how much work you should do. This is how much work you should show. When you do this, and get it under control and have it as a practice habit, it doesn't matter how big the problem gets, doesn't matter how complicated the problem gets, because you know how to use those inverse operations. What you do to one side, you do to the other. You know that you need to keep an eye on the integers. You know that you have to take that solution, put it back in, and double check to make sure it works. If you do these things, then you know that you're on track. We're going to try 3 more examples here. This was an addition problem, so now we're going to take a look at a subtraction problem. Here I have negative 8 93/100 minus the variable v equals negative 27 93/100. So this is kind of what it looks like if I was to picture it. We see that our variable is upside down. Well, it's upside down because it's a negative. So we want to make sure that we understand that it is not a positive variable, it's a negative variable. It's the opposite of the variable we want, because we know that a negative sign means the opposite of something. So we got to keep that in mind, and that's going to travel with it. It's got to stay with the variable. So let's talk about what we would do. I would want to take away this negative 8.3, right? So we're going to put a minus sign in front of it. Taking away a negative. What does taking away a negative mean? Well, a taking away, if we change that negative, that minus sign to an addition sign and take the opposite of negative 8 93/100, we would get positive 8 93/100. So when really we're going to do that to both sides. So I'm going to bring over my division, my split bar here, and split my sides. I am going to add 8 93/100 to both sides, because that's what I'm doing when I'm taking away, right? So we're going to do that to both sides and draw my line. And when I simplify this, I will get, remember, it's the opposite of v, so we're still got that opposite of v going on. And when I subtract these two, because they are opposite signs, and so that really means subtraction, we have more negatives than positives, I will have a net of negative 19. Now what this is saying is the opposite of v is negative 19. So if I was to flip this over, this is a negative. If I was to flip it over, like flipping it over to the other side of the number line, I would have to make it positive. So that's what I have to do here. So if the opposite of v is negative 19, v has to be 19. Now, we can do this like I just did through deductive reasoning, but we can also explain this a little bit more through some math. So I'm going to show you that as well. If you have a negative number, okay, if you have, let's say, negative 3, the way I can change negative 3 into a positive number is I can do one of two things. I can either divide it by negative 1, because a negative divided by negative is a positive, right? Or I can multiply it times negative 1. Either one of these things is going to turn it into this positive 3. So theoretically, what's happening with the v is if I multiplied both sides by a negative 1, which I'll do right here just to show you, we know that now that negative sign went away, and this now two negatives, a negative times a negative, would give us a positive. So we need to check our solution. So I'm going to bring our squiggly line here to keep our side straight. And negative 8 and 93 hundredths minus v equals negative 27 and 93 hundredths. Bring my sides in here to keep these apart. Now, I said we're going to erase our variable right there, and we're going to put in that spot the number 19. Now, what's interesting, and I think you can see this, see how it says that negative v is negative 19? It really is still here, isn't it? It's still there. It hasn't really disappeared. It's still showing up, so we can still see that. So we have to remember a little bit about our integer work. If we're subtracting a negative, we're basically adding these two negatives together. So if I add those two negatives together, I will get negative 27 and 93 hundredths, which is exactly what I wanted to get. So this indeed is our solution. Okay, that one was a little more involved. Let's do a multiplying problem here. Here I have negative 18 and 9/10 multiplied times x, and that equals negative 315 and 63 hundredths. So once again, I'm looking at my diagram here, what I have. So if I'm multiplying by something, I want to divide to get rid of it. So if I'm going to divide this by negative 18.9, what happens when I divide something by a negative number? Or I should say just a number itself. I'm just going to divide by this 18.9. Any number over itself equals 1. We know like 3 divided by 3 equals 1. Negative 2 divided by negative 2 equals 1. Because that equals 1, I can get a 1 here, and I know then that 1 times anything is going to be whatever anything is, whatever I'm looking at. So let's show that down here. Let's divide by negative 18 and 9/10. And I'm going to, oops, forgot to separate my sides. So I'm going to bring my little bar over to keep me straight. And then I'm going to divide this side as well by negative 18 and 9/10. So we're going to do some calculator work here. We're going to divide. We know a negative divide. We know this is 1, right? Like I just said, any number divided by itself is 1. So the big giant 1 times x, which is just x. A negative divided by a negative is a positive. And so if I took this number just 300, so we know that's our answer. And if we just take 315 and 63 hundredths, divided it by 18 and 9/10, you would get 16 and 7/10. Now we need to check and see if we're right. So I'm going to rewrite the equation. And I'm going to separate my sides. And I'm going to, it's going to have to squeeze it in here a little bit. I am going to get my x in here, right? So let me make a little movement here. See if I can get this to break up a little bit. Give me a little more movement. Maybe not. There it goes. I'm going to get these over here. Give me a little more space. Sometimes I write a little too close together. Thank you for your patience. Put our equal sign back in there. And we said that we were going to multiply. So let me multiply by this 16.7. So if I multiply these two numbers, a negative times a positive, I know that my answer will remain negative. And then I just have to use a calculator, 18 and 9/10 times 16 and 7/10. And I will get back to that 315 and 63 hundredths. So since both sides are equal, this is our solution right there. Okay, we're going to do one more problem. We're going to do a division problem. So here we have P divided by 19 and 5/10 equals negative 13 and 7/10. So what's interesting is I think a lot of students forget, and they always want to see this, they see this fraction bar and they always want to say over, over, over. It's really not over, is it? It really represents this division sign. So we're taking this P, this variable, what we don't know, and I'm going to divide it into 19 and a half piles. That's what I'm doing. I'm dividing it into that many piles. So if I'm taking this negative 13.7 and dividing it by that many piles, there's going to be a lot going on, isn't there? So let's see what that number would be. What number would I start with? It would probably be a pretty big number. So let's see what's happening. The opposite of dividing. Remember, we're coming back to that idea of any number. So if I'm dividing a number by 19 and a half, I would want to multiply by 19 and a half because that's going to equal 1. And then I'm back to where I was before. So let's do that. Let's multiply both sides by 19 and a half. Remember, that's over 1. And this side by 19 and a half. And I'm going to bring my bar over. Sorry, it was a little late on that. There. And I'm going to, here's my giant 1, right? 1 times p is p. And a negative times a positive is a negative. And 13 and 7/10 times 19 and 5/10 is going to give me 267 and 15/100. So we've got to check that solution out and see if it's going to work out. Once again, we're going to rewrite our problem exactly the way we saw it. I'm going to separate our sides. I'm going to erase my variable. And I'm going to put in that variable spot the number I came up with, which was negative 267 and 15/100. I know a negative divided by a positive is a negative, and with my calculator I can find out that 267 and 15/100 divided by 19 and 5/10 will give me 13 and 7/10. So since both sides are equal and it checks out, this is our solution. So hopefully you've been able to understand one-step equations a little bit better, more on the 7th grade level, because that's when we're using decimals and rational numbers, so that it can be a little bit more easier for you to do and get into two-step equations, which is really where we need to do the work.